By the end of the flood, the Earth was at its warmest period. Volcanic activity, replacement of oceanic crust with magmatic crust, and so on. All these things heated up the ocean water during the flood. We estimate 20 degrees centigrade, from about 5 degrees centigrade before the flood to 25 bathtub water, about 78 degrees temperature, average temperature for the ocean by the end of the flood. And then it cooled off to the present, which is again at about 5 degrees centigrade is the average ocean temperature. And the cooling occurs by evaporation. Evaporation actually cools the water. And then, of course, the evaporated water moves over to the land and drops down, releasing its heat energy by radiation into space. And that cycle cools the oceans down. We suspect that immediately after the flood, this process was accelerated by the development of two hypercanes, one in the North Atlantic and one in the South Pacific. A hypercane, if this was a picture, this isn't a picture of hypercanes, it's a picture of a normal hurricane, so scale is off. But let's assume this was a picture of the North Atlantic hypercane. Greenland would be about right here. Western Europe would be about right here. And Eastern Canada is here. And we suspect that hypercane, hypercane means big, it's a big hurricane, sits over one place for centuries. We suspect it sat there for a couple of centuries, and you know what happens when a hurricane stalls on the coast. It's really bad. Sucks up lots of water from the ocean, dumps that water on the land, huge precipitation and so on. We suspect there are two of these, one over the North Atlantic, one over the opposite position in the South Pacific, over Antarctica, and that this was a large part of the cooling process during the flood. Now, we have been observing some hypercanes for the last couple of centuries. The Great Red Spot on Jupiter is a hypercane on Jupiter. Been sitting in one place, size of the planet Earth. It rotates around the planet, but it's in the same latitude, and it's been persistent for centuries now. But it's a hurricane, very large hurricane. I would suggest hypercanes are talking about a climate very much different than the present. It's a wild climate. Those are two places in between because of the temperature difference between the ocean and the land, because the land cools off very quickly as it rotates away from the sun, cools off by radiation into space. We have very, very high temperature gradients between the ocean and the land. You'd have very violent climate in the post-flood period. Huge amounts of precipitation. We suspect immediately after the flood, we're talking an average of hundreds of inches per year at any average location away from the hypercanes. So the highest rainfall on the present planet recorded in Hawaii is what we would expect to be the average rainfall worldwide. So under these circumstances, we're going to be able to build up humongous lakes. We're going to be eroding huge amounts of material off of the mountains and creating pediments and peneplains and all of this sort of thing, and don't have time to get into that. A large warp in the crust caused by a piece of crust that was pushed underneath the continent during the flood and caused the Kaibab upwarp, created a place for the accumulation of a bunch of water, we believe, upstream from the Kaibab upwarp, about 10 times the amount of water as is found now in the Great Lakes, 5,000 feet deep at the eastern edge of the Kaibab upwarp. We believe that either topped it, or my suspicion is it actually made its way through a layer of limestone, the Redwall limestone, creating caves and then collapsing those caves to create a notch, releasing those upstream lakes to produce the Grand Canyon in probably a few weeks' time. I believe that the caves, the thousands of caves, where I used to live in Dayton, Tennessee, we estimated about 8,000 caves are within 100 miles of Dayton, Tennessee. And I suspect all those caves were formed in the matter of hours over a several-week period of time during the release of similar lakes that were associated with the Appalachian Mountains. And so we have rapid rapid creation of caves and canyons. I suspect that all the canyons of the world were formed during this period of time, this Arphaxadian epoch. Current rivers tend to cut laterally and do not tend to cut vertically. In fact, I don't know of any river at this point that actually cuts into its bed. Every river has about 40% of its canyon filled with debris, and it doesn't even move the debris, let alone cut vertically. So I believe canyons may only be, it's possible that canyons are only cuttable in catastrophic conditions and under the conditions of this extraordinarily high rainfall and precipitation period. As this drops, it gets to a point where actually we suspect that when the hypercanes cooled the ocean down to such an extent that the hypercanes collapsed, by that point in time the precipitation had changed under the hypercanes from water to snow, thus producing the ice packs on Greenland, eastern Canada, Antarctica. Those ice packs would then actually surge very quickly under their own weight. They're actually produced so quickly that they certainly can't melt, and they actually surge at probably meters per hour down to the south to produce the ice age as it's typically understood. The collapse would also change. We estimate, at least the work of Larry Vardaman suggests, that we go from a 2 Hadley cell convection system to a 3 Hadley cell convection system we have today. Today, the air in the tropics rises because it's warm and carries with it a bunch of water, of course. As it rises, it drops that water out because it cools by adiabatic expansion as it rises, and so it wrings out its water. It then comes back down. Now that it's cold, it comes back down at about 10 degrees north and 10 degrees south, and it's dry air. So when it hits the ground, now warming under adiabatic compression, it now creates deserts at 10 degrees north and 10 degrees south. And then some of the air moves back toward the equator. Another packet of air moves away, gradually picking